with any model that I usually build, I start with some sort of scruffy sketch, and I'm going to put that in the modeling window using the picture command. And it just so happens that I have a scruffy sketch here that we're going to go ahead and use. You can see it's even labeled scruffy sketch. You guys are like, yeah, that is a scruffy sketch. So what we're going to do is build this like, potato chip bag closer thing. So here's my sketch. And basically what I do is I drop it in the front window because that's what I'm going to be working in most of the time. And I like to take this and slide it out of the model space. And the reason I do that is because if I were to build a model with the sketch centered, this is what happens. The sketch splits right through the model, and especially in shaded view or something like that, it becomes difficult to kind of work on the model. Whereas if I take this and slide it back out of the model space, it's out of the way, but from the front view, I can still see exactly what's going on, okay? So I'm gonna stick that back there. The other thing I'm gonna do is I'm gonna just take a second and I'm gonna draw a straight line here and just compare it to my model. And you can see that even though this sketch is like horribly asymmetrical and all that kind of stuff, I am gonna actually try and rotate it just a hair so that it's at least some semblance of straight, and then we'll have to pick which side we want to work on and all that kind of stuff, but at least we're going to start somewhere close to straight. So I'm going to make a new layer and go to my layers palette. I'm going to make a new layer here. I'm going to call this sketch, and I'm going to take this and I'm going to right click and change object layer, and then I'm going to lock it, and that allows me to be able to work over this without having to worry about selecting this and moving it and all that kind of stuff. Now, one last thing I'm going to do with the sketch is I'm actually going to change its transparency, because right now if I try to draw over this thing, because my default lines are black, it becomes very difficult to see where my lines went. So I'm going to actually unlock this for a second, pick the sketch, go to my properties, actually I'm going to go to my materials, and you can see that my sketch is lit up here. And then I'm going to just drag the object transparency up a little bit and make it more transparent, somewhere around 60, 70, 80, something like that. Back to my layers, and now we're going to lock. Now we can work over it. We can see what's going on and all that kind of stuff, okay? Actually, I'm going to unlock one more time, and I'm going to actually try and like vaguely center this over the origin. And I'm going to use this center circle as kind of a reference, and then we'll draw one side of it, flip it. We'll decide how close we are to symmetrical from there. All right. You guys are like, wow, this is really informal. Yes, it is. That's the whole point. All right. So the way this thing is built is it's basically an extruded shape, and then it's got a wall thickness, and then it has a profile to it. So if we were to look at this in two views, right, we've got our exterior shape here, and then we've got our side view shape, and then we've got our little bitey teeth down here and stuff like that, and those spring, and we'll worry about that later. But in order to get the main shape of this thing, we're just going to go ahead and draw a profile. And there's one little faded detail on here that we'll worry about later, just to give it a little bit of style. I added that. Maybe we'll put it here. Maybe we'll put it on the handle. We'll see. We'll decide where we want the detail as we get this thing built later. But the first decision I have to make is, do I want to build this with polylines, meaning do I want to build without fillets for the corners, right, like this, or, and then do I want to go back and mechanically fillet each one of those corners? The pounding has started, sorry about that. Or do I want to draw the fillets in from the beginning using my original curve? And I think I may actually draw them in. I may regret that later, but for now I'm gonna just draw them in. Go something like that. And then I'm gonna take and grab both of these points, and I'm gonna just make sure that they're lined up, and they are, because I don't have a scale handle. If they weren't lined up, you'd be able to see it, because if I picked this point and this point. See how there's a scale handle here? If I want to fix that, I can just click and do 0, and those are now lined up because the scale handle's gone. And then I can put these at 0. And I can even make myself a little reference point. I'm going to just drop a point at 0, and I'm going to use snappy dragging with gumball. This is a cool trick. If I drag and then enable my O snaps by hitting the Alt key, see how the gumball snaps to that point? And now I know all this stuff is lined up. Okay. If you haven't used snappy gumball before, or snappy dragging on your gumball, I think it's smooth by default. It's a setting down here in the gumball, so you want to check snappy dragging, and that allows your gumball to respect your O snaps. Now, I can look at the shape here and decide, do I like this little, this is, you know, we're going to get fussy here, but do I like this little kind of rise in this curve like that, or do I want it to be flatter? If I want it to be flatter, I have to flatten these things to 0 and then snap them down here. That gives me a flatter profile. I actually think I liked it before, so I'm just going to undo it. Oops, too far. And then let's go ahead and mirror it. And then we can take these and join them into one single profile. So that's the basis, you know, that we're going to use for this model. And then what we can do is just extrude a closed planar curve. And I'm just going to extrude this into a brick. It doesn't really matter how much of a brick. It's just going to be a brick for right now, and that's fine. And then what I need is I need to actually figure out what this profile curve looks like, because I'm going to take this and send it through this thing as a wire cut and get this shape. So basically we've done, if you've ever done foam models, right? We just made our first bandsaw cut through here, and now we're going to make a second bandsaw cut through this direction. All right, does that make sense? So then I have to decide, like, how do I get this profile here? And there's a couple of ways I can do it. I can either just draw it in this view and then go to the perspective view and rotate it, which is probably the easiest way to do it. But I can also unlock this. I can copy and paste this sketch, and I can rotate this sketch and then go to the right view and drag this so that I can see what I'm doing. And I'll probably pull it. See how it splits the model there? We don't like that. Pull it like this, and then work from that view so we can kind of see what's going on. And in fact, it's actually just a hair too big, so I'm going to scale it down just so it fits in there like that. And then I'll probably lock this again, and then we can now draw our profiles, right? So I'm going to overdraw these because I'm going to come back and trim them up later. So I'm going to overdraw it. And it's got like a little bit of a designery profile to it. Whew, missed that one by a mile. And the model, see the curve is right in the center of the model, so I'm going to move it out here so I can see it. And then turn its points on. Which points on are over here. And then just gumball these things back into shape. Something like that. Take this curve here. Do something like that. And again, this sketch was pretty clearly pretty rough, so I'm going to use Rhino as my final decision for design as opposed to the sketch. I'm going to kind of use the sketch as a guideline and then come back and say, well, I don't really like that relationship. I don't really like this relationship, so let's make it a little less scruffy in the model, even though the sketch is pretty rough. No one cares about the sketch because after the model exists, the sketch is a non-issue. All right, so here's the profile that we're going to do, and I'm just going to go ahead and connect one end of this. And the reason I'm going to do that is because when I wire cut, it only allows me to wire cut one side at a time, right? Or one curve at a time. If I connect these, ta-da, it's one curve. Wire cut, select this, right through the block, I'm going to go, the direction is C-plane normal. I'm going to go ahead and delete the input, and then I am not going to keep all. Went the wrong way. Select object to cut. Actually, I'm going to keep all. There we go. So now I've got 3 pieces. I'm just going to delete these. And I've got my main piece. Now, I have a decision to make. Do I go down the road a little bit before I shell this, or do I shell it to get my wall thickness now? And because this is a really simple part, I could very simply just copy this face and keep it for a later date, offset this, and then make that an extrude block. Or I could use the shell command and I could remove this face for now. Let's see what I didn't even look at what the size of this thing was. That's actually a little too small. There we go. Maybe a little bigger. I think I'm going to shell it now. I might even go a little bigger. This is obviously a very big clip if I'm using a 1/4 inch wall thickness. I didn't do the scale on this thing when I built it, but I'm just looking at trying to eyeball it to get a decent wall thickness here that works. And I'm going to say, I might even go one more. Let's go 0.3. People are like, wow, he wasn't kidding. Okay, so now I took this far enough that what's happening is it's offsetting to the point where the model is self-intersecting and it can't complete the shell. So I'm going to back up one and see how thick I can get before it comes apart. Looks like 0.25 was about as good as I'm going to get. There we go. Okay, so we've got our wall thickness. It is solid. We can check it with our show edges. No naked edges, no non-manifold edges. Lawrence, you said, can you explain that message a little bit more? Are you talking about the shell offset? All right, let me see if I can explain this. So if I have a corner like this, right, and I were to offset it, let's go ahead and offset it. Actually, I'm gonna explode this because I think the curve offsetter actually solves for this where the surface one does not. But I'm going to offset this one 0.25, right? And then I'm going to offset this one 0.25. This right here, if this were to be attached, it's called a bow tie. This right here. Boop. This little scenario right here is called a bow tie. And what happens is when you offset something, right, it comes in this way and it has to go parallel to what it's offsetting. If you offset a surface to the point where it can't resolve this intersection right here, if it can't do this and create this corner, you get what's called a bow tie. And bow ties and surfaces are no bueno, right? It will make the shell fail. And that'll happen in a situation like this, where there isn't very much surface. Let's see if I can get there. There isn't very much surface here anyways. And so if I offset this surface from this surface so far that this surface makes this surface go away, then what I actually could get is, let's see if I can fake it and show you what I'm talking about. I'll actually get a scenario where I'll get this, and then there's not enough surface here to contact it, and so then I get this weird turny inside-outy part, and then the shell will fail. Okay, so that usually happens if, say for instance, you have a corner that's filleted. Let's see if I can draw this again and show it. Does this make any sense, or am I just rambling and you guys are like, what in the world are you talking about? If I were to fillet this, let's do a bigger fillet. Okay, good. I was like, I'm confusing myself. I hope nobody else is confused as I am. Oh man. All right. So as I do this, and if I go, let's say 0.5, see how it'll go that way because everything is going perpendicular and it's going out, and it can resolve that. If I go in, see how it crosses over itself? Now, the curve fileter actually solves for that and trims the bow tie off. The surfacing one does not. Well, it does a little bit, but it has a limit, and it's much more fragile than the curve offsetter is. But that bow tie is what causes the shell to fail. So strategies for using shell. One, try to shell early and then save the shell. Like what I'll actually even do sometimes is I will actually peel this model apart, and I'll take like this piece alone and I'll stick it on a layer and save it for later, right? And I can either use this as a boolean object as I go through this thing, or I can make adjustments to it and stuff like that. So and it seems weird to do it that way, but if I were to have run fillets on this edge and then tried to offset, I would have gotten a really good condition to have that weird bow tie situation happen. And chances are the shell would have failed much earlier than it had I not shelled it, because the offsetter can fix this condition, right? It can solve for that a lot easier than it can solve for this. Okay, let's get a bigger fillet. People are like, wow, he really was not kidding about not rehearsing this. All right, so we got a bigger fillet, and if I were to explode this and offset this one and offset this one, you can see that the fillet has already been invalidated. So if I were to try and offset this thing, it's going to be an immediate bow tie situation. And so the sometimes, depending on the normals of this surface, and we're assuming that these are surfaces, I'm using curves, but if we're assuming these are surfaces, if the normal is pointing outward on this thing and we offset it so far that the thing turns inside out, and this one is still pointing out because it's just a straight line, what the surface does is it says outside, out, ooh, inside, outside, inside, what, and it dies, right? So whereas this thing, in this case, the normal goes this way, this it can still solve, the normal going this way, you know, it still can figure out what's going on here. So it just says, well, this is outside, so trim this stuff. When this normal gets flipped inside out, it causes this to get confused, and then it just dies. And the interesting thing about the way Rhino dies, especially the shell tool, if you were to do that in SolidWorks, the shell tool, if you were to put a situation in the shell tool in SolidWorks where the shell fails, it just says fail. In Rhino, when it fails, it will give you as much as it can, even though the shell isn't complete, to allow you to go in and manually model the rest of the stuff and save the shell. So if I were to take this thing, let's back up again and make it, I gotta go back a ways. Here we go. There we go. Oops, too far. If I were to shell this again, and I were to make this like 0.5, and it fails, see how it says the shell's not solid? But what it did when it failed is it gave me as much as it could, right? This can allow me to actually come in here and dissect this. In fact, you can even see the bow tie. Oh, thanks, Rhino, for making my point for me. See this? So I can actually come in here and explode this, and then come in here and do something like this where I split. If I explode this again, can't explode that. So let's split this by an isocurve. And I can actually manually remove the bow tie. See that junky spot right there? I'd have to untrim that. And it allows you to go back in and fix this stuff, right? Then I could come in here and I could blend surface this back in. Well, I'd have to pick it. I have to do it the right way, but if I did it the right way, it would work. There we go. then I could actually go in and repair this and manually build the shell and get the wall thickness that I asked for, even though the automatic tool didn't work. All right, does that make sense? All right, I beat that to death. That'll teach you for asking questions. He told us to ask questions. Yes, I did. Okay, so let's shell this what we asked for before, which was 0.25, and we'll get this show back on the rails. All right, so we've got this piece, and I have to decide like what I'm going to do out here, because if I were to round this edge or fillet it somehow, if I were to round this, what's going to happen is, because this is a pointy edge inside, right, in here, then I'm going to get a scenario that looks like this. Pointy edge, and then I'm going to get a smooth edge that gets really close in that corner, right? So I have to, if I fillet something on the outside, I have to go back in and fillet something on the inside, right? In other words, so that I don't end up with this tiny little thin pinchy spot. So I have to keep that in mind as I'm going, right? Which is one of the reasons why you have to decide, do I shell early and then keep that in mind and work with that, or do I shell much later, or do I shell early, take the piece out and save it, and then work on the thing as a solid piece? And then, you know, there's all these different strategies in order to be able to work with wall thickness parts. For something this simple, I tend to shell early and then just work inside, outside, inside, outside, inside, outside, instead of, you know, worrying about it too much. But let's go ahead and add some more detail to this thing. Now, it has pointy teeth down here, right, along this edge down here at the bottom, where the bag clips together. So I'm going to pull a trick with this, where I'm going to actually extract the surface, and I'm not going to copy it. I'm just going to pull it out for now. And I'm going to use split, but I'm going to right click it and split by isocurve. And what that's going to allow me to do is to come over here and actually split this surface in two places. And ideally I would have paid attention to like exactly where I'm splitting and all that kind of stuff, but I'm not going to worry too much about that, because I can always cut the model in half later and deal with it. Now I'm going to pull a trick called subobject selection. Or actually, I'm not even going to do that because it's not a subobject at this point. But I'm going to pick this surface now, and I'm going to extrude it out to give myself the space I need in order to make those teeth. Now, if I look at this object, right, it has a back on it, and I don't want that back. So this time, I am going to subobject select by Shift-Control-Click. I'm just going to delete it. So I'm going to leave it open in the back so that when I bring this back, I join this all up. Now this is a closed surface, right? But I've got this extra little appendage out here that I can then make my teeth with. Does that make sense? All right. So now I can go to the top view and I can just draw my teeth. And I'm going to just draw one and copy it. Let's line it up. Something like that. This is going to be a super precise model. And I'm going to use the copy command. And I'm going to pick this object to copy. I'm going to copy it from here to here to here to here to here to here. I'm going to just get to the center point. I'm going to join this all up, and then I'm going to set my gumball with gumball relocate to here, and then I'm going to snappy drag this to the center line, which allows me to be able to clear this curve so I don't have to make all those copies, and join it up. All right, now I freely admit that I did not pay any attention to whether or not this thing was symmetrical, this piece here, whether this was symmetrical or not. So chances are I'm going to have to just cut the model in half and flip it, which is fine. I'm going to just go ahead and deal with that. All right, but I'm going to take this and I'm going to wire cut this through directly in this direction. And what it does is it just bites out all these little teeth. So wire cut is actually a boolean function. And so what it does is it's a little bit, it takes the wire cut, it takes the curve, turns it into a surface, runs it through, makes a boolean, and then gets rid of the curve, gets rid of the intersection, allows you to just make these little things. So I hate that. So let's go ahead and undo and fix that, because I don't like that little piece. So I'm going to scale in one direction from here. So that way I don't have that little hook in there like that. And I think I'm deciding that I'm going to keep the left side of this model. That's better. Okay. And I don't like this side of the model. I think I'm going to keep this side of the model. So let's just rip this thing in half. I'm going to make a center line at 0. And I'm going to just trim. I'm going to take this and mirror. Now we've got a symmetrical part again. Okay. So let's go ahead and start doing some rounding here. I'm going to round this edge off, and I'm actually going to use blend instead of fillet because I just like the way they look better. And I think the radius on this, I think I'm going to go like, I don't know, let's start with 0.15. Oof. Let's start with 0.15. I don't want to get crazy. And let's just see what it looks like. I'm going to preview it. That actually is not terrible. I might want to go just a hair bigger, so let's try it. I actually like that better. So let's run that. Now, remember what I said about that little pinchiness? If we look, you can see it's not too bad in here, actually. It's actually close enough that I'd probably leave it, but just for the sake of being fairly comprehensive, let's blend this again. I am not going to use 175. I'm going to go like maybe 1, because the fillet has to get smaller. And you can see that it didn't like that, which is one of the nice things about the preview. You can see if it's going to fail. So let's go and set all and do 0.08. And it liked that, so it went ahead and did it. So we'll run with that. And then we'll just check our edges to make sure. Ooh, it's got one naked edge. Let's see where it is. Zoom. It's right in this corner over here. So something about this corner it didn't like, but because we made this model symmetrically, I'm not even gonna worry about it. I'm just gonna just cut this thing in half again, because the other side of the model's fine. I could stress out about that. I could say, well, why did it fail? I need to fix it. Or I could just go, shut up and do it. I prefer the shut up and do it. Okay. So fixed, gone, done. I have very little patience for stuff that doesn't behave, and so I usually just throw it away and get rid of it. What was the command to split? It's over here, split and trim. Oh, using the line, you mean, to do the teeth? That was wire cut. This one, wire cut. Things to know about wire cut: it has to completely go through the model. You cannot wire cut that. It has to do that. Okay, it has to be complete. It has to follow the same rules as booleans. It has to make a full connection. Okay. All right. So now we're in a position where we can take this thing and actually flip it and start thinking about how these two pieces relate to each other. So let's go ahead and make the second one. And I'm going to have the teeth touch end to end. I'm not going to try and make them intersect, because A, I'm lazy, and B, we only have an hour. And C, so far my construction guys have been quiet, so I'm going to just roll with it as fast as I can. So won't you need the spring holder? Yes. You're jumping ahead. We're getting there. All right, so now I need to make the little fingers that interlock between each other, and I'm just going to draw that out. And I'm going to use a rounded rectangle, and I'm going to draw that out something like this. I'm going to overdraw it a little bit and bring it back, and I'm going to put it here, and then I'm going to rotate a little bit. This is obviously a very precise operation, you can see. And so that's going to be one side of it. I'm going to trim this off. Actually, I want to make sure that it intersects through the model, so I want to trim it off back here. And then there's a cool command called close, which just takes an open curve and throws a line in there to make it closed. And that allows me to then take this, and I'm going to just extrude planar curve to make this little rib. And then I'm going to just drag it into place. And then I'm going to mirror it around 0. And that gives me my one side. And then I'm going to take these and go to the right. And I'm going to mirror them around 0 again. Oops, now I'm going to mirror them around the end of this thing. Would have been nice if I would have built this around the origin, but. And they don't quite intersect. So I think what I'm going to do is I'm going to draw these a little bigger. So I'm going to move this so that they kind of do this. It's kind of what I'm looking for. And I may actually want to grab both of these and kind of center them like that. And it doesn't quite line up like that. So I'm going to take these two. I'm going to take actually this one and tuck it inside. And then I'm going to mirror it. And that way I've kind of got, I'm kind of set up how I want. And these don't intersect the part, which is fine, because I'm going to do a sub-object selection. And I'm going to set this to align to object, and then just go boop, like that, right? Now this is ugly. It's got like a little weird, like hacky little spot here. So let's fix that. So I don't like that. So let's just draw a clean line through here, like this. And if I was being really fussy, I would make it perpendicular and snap and all that kind of stuff. But cap, sub-object select, click. My gumball set to align to object. Just go bloop like that. I'm going to be lazy and just mirror it. And this is a cool trick. If you take this, see how it's got a surface here and a surface here and surface here and all that kind of stuff. Let's do merge all faces. And you can see that it'll clean up most of that. Now these weren't, perfectly planar, so it didn't necessarily fix them. I can either see that as a problem or I can just roll with it. You can actually see the dent in that thing. Ideally, we should fix that. So let's go ahead and do it. So this is garbage and that's garbage. There's a little garbage surface in here, that one and that one, which also means that unfortunately this face and this face are also junk. So let's get rid of them all. And then let's just put it back together right. So that's now a straight surface, just using loft. See, I told you I was going to mess stuff up. And then we'll cap. Now it's nice and clean. See, it doesn't have any of that other junk in it. And then we'll mirror it. All right, so this one is intersecting properly. In fact, actually, we did it in a way that it doesn't even blow through the model, so we're in good shape because you can see that it intersects here, but it doesn't go all the way through. So I'm going to delete these bad ones. We'll go here. I'm going to mirror from the center of this, like that. And we've got these set up in the right way. I'm going to move this one in like that. Actually, just mirror this one too. Try to keep some semblance of symmetry now that we've established it. And then I can either decide, I can make a decision and say this is either going to be a premium chip clip / hair accessory, and it's going to have a metal axle through here, or it's going to be a really cheap one like the garbage one I have sitting on my desk right now, and it's going to have a plastic post in it, which means I'll have to connect this one and this one with the post and then make a boolean through here, which I think is more interesting, so let's do that. And by the way, we're really close to being done here, so if your attention is starting to flag, buck up, little camper, we're almost done. And then we need to have a discussion about why your attention span is only 39 minutes. All right, so we'll make this a boolean. So we've got these two connected. Let's bring this back. I'm going to stick this one to this one now with another boolean. And then I need to make these fit this. And what I'm probably going to do is I'm going to just boolean these out for now so that I can see what I'm doing. So I'm going to do a boolean subtract from these using this, but I want to make sure that I don't delete the input. So now it just makes the hole in there like that. But the way that this is put together, I won't actually be able to use this because there's no way to assemble it. So what I'm going to do is I'm just going to hack from the center something like this. I'm just going to hack it off because the spring is actually going to hold this together. Trim those off. I could have wire cut that and it would have given me these surfaces for free, but then I wouldn't be able to show you the cap feature. So it's not stupidity, it's teaching. All right, so then I'm going to boolean this together. So now I've got my two pieces. All right, now here's a cool thing. There's a new feature in 6 called named position. So I'm going to take this object and I'm going to name it position 1. We'll call this closed. And then I'm going to take this, I'm going to move my gumball to the center, and then I'm going to rotate this open, and I'm going to save a position. I'm going to call this open. So now I can go bloop, 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 bloop. Just load that open and closed. So if I'm doing a presentation, this is what it looks like closed. For people who have never seen the advances in chip clip technology, where they know that we now have open and closed, we can show both modes. Fascinating, the crowd goes wild. All right, so let's talk about the spring. And I actually have to look at the one that's sitting on my desk to figure out exactly how this works. But basically what it does is the spring starts in the center and it bends out this way and then goes in the front, and then it bends this way and goes in the back. And that's probably the most awful explanation of how something works that you've ever heard, but that's where we are. So let's start here and let's draw this. And I'm going to pull this out like this. And I'm going to pull it across like that. And I'm going to do this with a curve just so it's easy to manage. And I'm going to hide all the other curves. And in fact, I'm going to hide my images because they're getting in the way. And I don't even need those curves anymore. I'm just going to bring this guy. Where does he go? Kind of goes above that. Get rid of these. All right, so I'm going to turn the points on for these curves. And then I can just start pulling points and put it where I want it to be. I'm going to use the transform waffle here so it only moves in the YZ plane. And then I'm going to do the same thing over here. I'm going to set this to align to world. I'm going to pull this down like this. So that's vaguely what that spring does, right? If I'm looking at it correctly. I'm looking at it in front of my face right now, trying to see if I did it right. Yeah, not bad. All right, I'm going to use a command called fillet corners because this is a polyline. It's going to fillet all the corners at the same time. Fillet corners. and this is the polycurve to fillet, and the fillet radius, let's try 0.2 and see. That's actually not terrible. And then we're going to use the pipe command to actually turn this into a wire. And we'll make it something that humans can actually use and not the world's strongest spring. That actually might be too big for that corner. Nope. It's a kind of a burly clip, but it'll do its thing. Now, if you notice down here, maybe you didn't notice, but I'm going to point it out. There's record history and update children down here, which means that this object actually was created off of this curve, which gives me the opportunity to repick this curve and actually adjust it, and the object will update by history. So if I grab this curve and I turn on its points, and I grab the points and I move them, that will update. And it looks like something broke. Let's see what broke. Looks like it smushed that for some reason. It didn't like that. Didn't like that edit. So let's see if we can grab another point. I think it's this point here that it didn't like moving. Didn't like not moving, by the way. And then let's rotate from here. And let's pull this in. Let's see if that works better. Because what I want to do is I want it to sink in a little bit. Looks like it still broke. So I think what I'm going to do is I'm just going to redo the pipe. So if I grab these points, and I go from here to here, I'm going to just pull this in. I'm going to do the same thing over here. I'm going to grab all of these points. Would have been cool if history had worked. Guys would have been super impressed, but that's not how the day is going. Sometimes you're the puck and sometimes you're the stick. All right, so let's look at that. Because what I want is I want the spring to actually intersect in with the clip a little bit, which means actually I want to pull this point through here for now. Like that. And then we'll pipe it again. I'm just going to right click through it because I want to use the same settings I did before. See how it's intersecting now? Now what I can do is boolean this from using the spring, and it makes the little spot for the spring to fit. All right, I'm going to shorten this a little bit by doing a sub-object selection. I'm just going to push it back, Control Shift click, drag, Control Shift click and drag. Doesn't like that. And it doesn't like that because there's a degree 3 surface in here somewhere, so I'm just going to trim that one. I made the little L on the end of that so it was a little easier to catch when I got it off the model. And I'm just going to cap. And now we've got basically our finished little model. Now, the last thing that we can do is just add that little fading detail. And at the risk of angering the construction gods here, I think I'm going to go for it. So the formula for making a fading detail is this. We'll start with the outside shape. I'm going to just mirror this so it's symmetrical. Then the inside shape. And then we need a bottom shape here, like that. All right. Then what we're going to do is I'm going to extract these three this surface right here, and I'm going to just keep these curves. hide everything else so that we're just dealing with this. I'm going to join this. And then what I'm going to do is I'm going to actually split this surface up into a bunch of pieces. So I'm going to use split, different than wire cut. That's the object to split, using all of this stuff. Now, this is a throwaway piece. This is the piece I want to keep, but I want to, and what I'm going to do is bend it. Let's get rid of the curves for now. But I'm going to bend it using its points. Can't bend a poly surface, so I have to explode it into pieces. I'm going to use a command called shrink trim surface, and it's going to reduce the amount of points into the bounding box of the object. Now, the cool thing about this is if I bend the points, if I grab these points right here, leave the bottom ones alone because I don't want to mess with that connection. If I bend them, and I'm going to start up here in like this, what it does is it leaves this connection alone. I should be able to join that up and have it be joined. And then I just use blend surface between these two. And I get a nice fading detail. Gotta hide my curves. There we go. Helps if I have a better material on here, but looks like my lighting is all wonky. What's going on with that? Let's put a material on this and see if this improves. Let's make that a plastic. There we go. Make a different one. Let's actually make this a less terrible color. There we go. Then we've got our little chip clip, right? And I'm going to skip the detail on the back. You guys get the point, but that's kind of where we're at. All right, go into shaded mode. We can see what we've done. Last thing that we want to do is pre-flight check this thing. We want to run cell open poly surface. And you'll see that it's got an open poly surface on it, which means that this will not rapid prototype. So let's figure out what's wrong. Using the isolate command, let's look. Oh, I can see exactly where the problem is. I forgot to join this in. Derp. So let's join it. Now we have a closed poly surface. Let's bring everything back. Cell, open poly surface. Nothing should light up. And because it doesn't, that means that all of these parts are solid. And if I were to export them, as an STL and send them to a printer, they would print. If I were going to send them to SolidWorks or Pro E, they would most likely import if I built these to high enough tolerances and things like that. So this is actually a pretty decent model. The next thing we want to do is run check. Check everything. We want to see valid, 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 valid. And if this was a huge model, this would be a really long list. The trick is to scroll through it quickly. And if I were to, let's hide all the curves. If I were to have, let's say this model was like, 500 poly surfaces. See how all these lines are the same length? If it says Rhino poly surface is invalid or open or anything like that, the line will be a different length. There'll be a scroll bar down here. As you scroll through it quickly, this will kind of blur into a gray if you squint at it. You'll notice actually if there's a longer or shorter line. So you can like go, and then you'll actually catch it because the pattern will be different. Then you can stop and see exactly which one, where the problem is, and see if it says it's open or broken or whatever. and then you have to go through and fix it. But that's another thing to check for. Questions? Let's see. So blend surface works when surfaces are not planar. That's when you would use loft, correct? Blend works on anything. It can be a pipe, it can be a planar surface, it can be a non-planar surface, it can do all this other stuff. The cool thing about blend is in version 6, it's historically enabled. So if I run this and get a blend with continuity, right? Position, tangency, curvature, it's also historically enabled. So if I move this, watch this, boop. Oh, it updates. It also, right? I know. Check this out, it gets better. So if I run this again and I say edit, select blend surface to adjust, everything in the scene that's got an editable blend surface will light up. If I click on this one, the handles come back and I can do this and change it and say okay. And then this is still got a history on it, but it'll remember those edits. And if I hate that, I run it again, edit, pick, fix the handles the way I want them, say okay, and it still has history on it. Now how much would you pay? $9.95 unless you're upgrading, then it's $4.95. That's how much you pay. Unless you're a student, then we give it away for almost free, unless you stole it, which most students do. Don't do that. All right, what else? I think that's about it. Oh, let's throw a little render on this. We'll just say ray trace mode, boop. And sell it. Unless you're a hobbyist, yes, want. All you have to do is enroll in a community college class, and now you're a student. All right, so you can see this rezzing up in the bottom corner. I've got a pretty fast video card, so it's actually rezzing up pretty quickly. But once this gets to about 1,000 passes, you'd be good to go. You mentioned the video. Will it be on YouTube? Yes. The YouTube is this one, Rhinoceros 3D. Go ahead and subscribe. All of the getting started stuff is in here. Also, a lot of the version 7 stuff. I've been doing a lot of version 7 stuff showing the subd tools. So if you're interested in that, which you should because they're awesome. All right, but it'll be here. It'll also be Vimeo if you're old like me. It'll be here. Let's see, where's the McNeil Vimeo? Here it is. Rhino Vimeo. Vimeo.com Rhino videos. I'll put it in the chat. So you can see this is rezzed up. This is our little rendering. If we wanted to save that, we would just go up here and say capture viewport to file or clipboard. We'll go ahead and capture it to a file. Say OK. Clippy. And we're done. Go make great stuff. Talk to you later. This is Kyle Houchins, and this is Getting Started Rhino for Windows. Thanks. Bye.